All right, welcome back, everybody, to a new unit. This unit is on similar figures, and we're going to need to brush up on ratio and proportion because that's used throughout the chapter. So we'll start out with ratio. Ratio is just a comparison of two numbers by division. So we'd say the ratio of A to B right here. So for an example of that, we would say maybe the ratio of two numbers is 3 to 2 with the word 2 in there. Normally, we're going to use a ratio as a fraction, so we can say the ratio of A to B is a fraction written like this. So as an example of that, the ratio of 5 to 6 can be written as a fraction like that. Rarely we see a ratio written as a colon, so from A colon B. So it's, for example, the ratio of 8 to 9 can be written as 8 to colon 9. But like I said, our main way to write a ratio is going to be with that second way of writing as a fraction. We already have experience with ratios when we studied slope. So we said the slope of a line was the rise over the run, the ratio of the rise to the run. So if you look at the graph of the line we have here, if we travel from point A to point B, we're going to rise a total of 4 units and run a total of 6. So we would say that the slope of that line is the ratio of 4 to 6, or we normally reduce to 2 over 3. So we have experience with ratios already. Proportions are going to be important to our work. A proportion is simply an equation, so you're going to see an equal sign in a proportion, an equation stating that two ratios are equal. So if you look at this proportion right here, these positions in this proportion have names. So B and C, so these two right here, these are the means. So B and C are called the means of the proportion. And the other two, the top left and lower right, those are called the extremes. So you got the means and the extremes of a proportion. Maybe one way to remember that would be if you were to write this proportion with colons here. So this says the ratio of A to B is equal to the ratio of C to D. The numbers on the outside would be the extremes, or on the extreme outside, and the numbers on the inside of the equation would be the means. So B and C are the means, A and D are the extremes, if you write it like that. If you write it like a fraction, you'll see, like we already said, that these would be the means right here. So lower left, upper right, and then these two numbers would be the extremes, top left, lower right. Okay, so the most important thing we're going to do with proportions is use them to solve equations. So we're going to need the cross products property here. So when you have a proportion, you can, well, we used to say cross multiply, and I hate to say that because some people interpret that differently. But if you multiply the extremes and the means together and set them equal, you have cross products. So if A divided by B is equal to C divided by D, then we can quote unquote cross multiply and say that A times D is equal to B times C. So to show how that works in the real life, with a real life example, let's say we have the proportion here, 1 over 3 is equal to 2 over 6. Check out the cross products. So here's the extremes right here, 1 times 6. And then so we multiply the other way, and you're going to see that 2 times 3 when you multiply the means is also going to give you 6. So the cross products are equal when you have a true proportion. Okay, so like I said, we're going to use these proportions, these ratios to solve proportions, and this cross product property to solve proportions. So here's an example of doing that. So we're going to solve for the variable y here. So you have the proportion 5 divided by y equals 45 over 63, and we're trying to find out what y makes this a true proportion. So use your cross products property. So 45 times y, so there's the product of your means, equals 315. That's the product of your extremes. That's 5 times 63. So that gives you this equation, and then just divide by 45, both sides, so you get y is equal to 7. So 7 is the number that fits back into that proportion to make it true. Here's another example of using the cross products property to solve a proportion. This time we have x plus 2 divided by 6 equals 24 divided by x plus 2. Again, we're going to multiply the extremes and the means together. So here's the product of the extremes. So there's your x plus 2 quantity squared on the left side of your equation equals 6 times 24, the product of the means. That's going to be on the right side right there.
Now we're going to take the square root of both sides here. So remember, when you take the square root of anything squared, that square root removes that square, and you're left with the part in the parentheses there, which is x plus 2. And then, of course, the square root of 144 we can simplify. We'll do that on the next step. So here's where you're at right here with that equation. Notice you do have the plus or minus there. We're going to have two solutions here. So the square root of 144 is 12. So we got x plus 2 equals plus or minus 12. Now we're going to write that as two separate equations so we can get two different values of x that are solutions of this equation. So x plus 2 equals a positive 12 and x plus 2 equals a negative 12. When you solve those two equations, we get these two solutions. So both x equals 10 and x equals negative 14 would make the original equation true if you plug them in. So two solutions to that proportion. Okay, so we have some properties of proportions that we should talk about. And so I have three properties and then examples for each one of them. So if you look at the first property, it says if we have a divided by b is equal to c divided by d, then you can cross multiply. So that's really our first property we've already talked about. That's a cross products property. And for that, I have an example. Again, 1 over 3 equals 2 over 6. Cross products, so 3 times 2 is a product of the means, equals 1 times 6 is a product of extremes. And so you see that 6 is equal to 6 right there. So showing that the cross products property works. Another thing you can do if you ever have the opportunity is if a divided by b is equal to c divided by d, you can actually flip over both fractions. So you can see we flipped over the left side to get b over a. We flipped over the right side to get d over c. And just to show you that that's actually valid, I came up with some numbers here. So let's say we have 1 over 3 is equal to 2 over 6. We would all agree that that's correct. Let's say we flip over both fractions here to get 3 over 1 equals 6 over 2. That's also true, isn't it? Both those fractions are the same thing as 3 when you reduce them. So there's a property of proportions that you might want to use sometime. And then another property of proportions that might be surprising a little bit. We'll start out that same proportion. So if a divided by b is equal to c divided by d, then what you can do is you can switch these two spots right here. And actually, you can switch the other two spots as well. It would work the other way as well. But I just have one example for switching these two spots. So then if that original proportion is true, then we have a divided by c is equal to b divided by d. And to show you that that really does work, let's start out with that same proportion to begin with. We have 1 over 3 is equal to 2 over 6. Let's just swap out then. Swap out the 2 and the 3 right here. Just swap them out. So we have 1 over 2 equals 3 over 6. And that's a true equation, isn't it? That's a true proportion. So it's just another property of proportions that you might want to use someday. Okay, to summarize a little bit, we just have ratios and proportions. Not a difficult topic. Ratio is just a fraction, basically. It's a comparison of two numbers. When you set two ratios equal, we have a proportion. The proportion has means and extremes in it. When you have the cross product, so the product of the means and the products of the extremes, they are equal. And we use that property to solve proportions for whatever might be missing, whatever variable we might need to in that proportion. And then we ended up with three properties of proportions, one which was a cross product property that we already talked about. The second one was that we could actually flip over both fractions in the proportion and it would still be true. And then the third one was we could swap out the means with each other, the positions in the proportion, or we could also swap out the extremes with each other in the proportion, and the resulting proportion would still be true. Okay, so you got a pretty easy assignment coming up, so let's go ahead and give that a try. Thanks. Bye.